and the assistant loco pilot would be sitting on the right hand side of him. So there are two people who are provided in the cab. One is the loco pilot, second is the assistant loco pilot. And we provide two people with the thinking that it's basically a safety precaution that as the train is run on the basis of signal aspects, and the train is approaching a station or leaving a station, the assistant loco pilot and the loco pilot both have to exchange signals and confirm from each other whether the aspect of the signal is the same or not, and before they proceed. Also, in a circumstance, sometimes what happens that the loco pilot unfortunately meets with an accident, or there have been cases where he has fallen sick or he has become unconscious. Then the assistant loco pilot has to stop the train, and he has to take all precautionary measures so that the loco should not go unmanned. So that is why two people are provided. And when you footplate also, you should keep in mind and observe this aspect, whether the assistant loco pilot has come only for a joyride or he's doing his work and he's exchanging signals or not. Now, when he is driving, when the loco pilot is sitting in the cab and he is driving, unlike an automobile or a car, all the controls are through the hands. So you will find that there are a large number of gauges here. There are some handles here, and this is another handle here. There's a speedometer here. So these are some gauges which are provided for him to have a look, so as to monitor the performance of the locomotive while on run. So there is something called an MR gauge, or a main reservoir gauge, which is telling him what is the pneumatic pressure of air which is available with him in the locomotive for the braking system. FP is feed pipe pressure. Just remember these names. This we'll discuss when we come in coaching. Then BC is brake cylinder pressure. And there's a huge speedometer which is provided in front of him. Now, this speedometer is a very important aspect, because when the driver is running a train, he runs to a specified speed. So, assuming he has to pick up a train from Baroda and he has to go to Ahmedabad. So, before the start of the train, the driver is given a list of caution orders which might be available. So, the driver would be said that at kilometer 120/1, you are supposed to execute the caution order at 90 kmph. Or say at another distance from this point to this point, you have to execute the locomotive at 60 kmph. So these are caution orders, and the driver cannot exceed the speed than what is written in the caution order. So when you footplate, you should first ask him that what are the caution orders which are available with him, and you will find that experienced drivers will execute the caution order at ±1 kmph. Assuming it is specified at 60, so there's a huge speedometer which he keeps on watching. He'll execute it at 61 or he'll execute at 59. Now the issue is, why such a huge speedometer and why right bang opposite him is, if he executes it at a higher speed, say at 65 or 70 kmph, he is stressing, he's providing stress on the rails more. So there's a tendency that the rail may spread and the loco may derail. If he is executing at a lower speed, assuming he has adopted a cautious approach and he's executing the caution order at 50 kmph, then he's losing time. So he is told that if you have to execute at 60, he should execute it at 60. If he loses time, imagine there is a train, even if he loses 2-3 minutes or 3 minutes on one caution order, and in a section he loses 10 minutes, the train which is following behind him is already late by 10 minutes. So that is why handling of the locomotive becomes very important. And when you are plating, you are also supposed to observe the handling of the locomotive by the driver. That is it is a part of his training. Each driver, when he is introduced on the locomotive, is trained how to handle the locomotive, and he is given something called learning road. So, for example, if the driver has to take from Baroda to Ahmedabad the train, he has been given learning road on this section. So he knows broadly where the signals are located, where are the caution orders, where is a culvert, where is there a level crossing. So it is ingrained in his mind, and that is how he can handle the train properly. Each driver is given a learning road to a specific section. So assuming the driver has been given learning road from Baroda to Ahmedabad, and you ask him suddenly to take a train from Baroda to Surat, he may not be able to do it, because he is comfortable only in the direction from Baroda to Ahmedabad. So each driver is trained accordingly, and these are some of the tools which help him to run the train. Now, if you come down on the cab, you will find there is something, there's a valve which is written as A9. There is a valve which is written as SA9. So these are braking valves. Now, if a train is running at 100 kmph and he has to brake the train, that means he has to brake the locomotive and he has to brake the formation which is behind him, the set of coaches which is behind him. Then he will use an A9 brake. Now, I told you that the braking system is on pneumatics, and with the help of this A9 brake, he is basically applying brakes in and in the train behind simultaneously. So these are called conjunction brakes. When he uses A9, he will stop he is applying braking force on the locomotive and the train formation parallelly, simultaneously. So the whole train formation will break. And when he has to again start, he will release these brakes. Again, the pneumatic pressures will built in, the brakes will release in the train formation and the locomotive, and again the speed will pick up. Now, assuming a condition where there is no train behind him and the loco is working light, that means he is working independently. He is going as a single head with no formation behind him. Then he is supposed to use this brake, which is called as SA9. Now, this is called an independent brake or a light engine brake. Now, with this brake, when he is using this brake valve, the brake application will happen only in the locomotive. So now imagine a scenario where the driver is running a train with a locomotive on the head and coaches behind it, and accidentally he uses an SA9 in place of A9. What will happen? The locomotive has braked, but the coaches behind have not braked, and the coaches will in turn push the locomotive, and it may lead to wheel skidding or it may lead to damaging of the loco wheel brakes. So that is why these are two types of pneumatic brakes which are provided. One is called A9, second is SA9, which are controlled by hands. Next thing is you will see a handle here. This is called a throttle. This is basically the accelerator in the locomotive. Now, unlike a road operation, the locomotive power is defined in something called notches. So the whole of 3000 HP or 4000 HP in the locomotive is divided into 8 steps. These 8 steps start from idle, first notch, second notch, third notch, fourth notch, up to eighth notch. Okay. So if the locomotive, if he has put this throttle position in idle position, the locomotive is producing 400 horsepower. If he takes it to first notch, the locomotive is producing, say, 600 horsepower. When he takes it to the second notch, the locomotive is producing 800 horsepower. Okay, so these are notch positions. When he takes the locomotive to the eighth notch, he is producing 4000 horsepower. Now, these are fixed RPMs of the engine with fixed horsepower. And how does the train speed get controlled? Assuming the locomotive is running at 60 kmph and he has to go to 80 kmph, he will simply notch up. So he will tell the engine that, look, you are producing 1000 horsepower till now, but I need to go from 70 to 80 kmph. Uh, Hence you start giving me more power. And when he notches up, he is asking the engine to deliver more horsepower. So there is no connection of the road speed with the engine speed or engine horsepower. It is decided by the driver. Assuming he is going at 100 kmph and he is finding that a down gradient has come in. If a down gradient has come in and he is at 8th notch and running at 100 kmph, he will notch down. So he will say that from 8th notch I have come down to 6th notch. So in place of 4000 horsepower, I am asking 3000 horsepower only from the locomotive now. And with this 300 horsepower also, I am able to maintain the speed of 100 kmph because I am going on a down gradient. So this is how it is connected. The engine speed and the engine horsepower are independent to the road speed, and the desired road speed is decided by the driver by notching up or notching down. By notching up, he is asking the engine to produce more horsepower. By notching down, he is asking the engine to reduce the horsepower. So that is from this device, which is the throttle. And there is also this which I have given you. Here there is a device which is called as reverser, which is fitted. Now reverser is a mechanical interlock, and reverser is provided only to decide the direction of motion. So reverser would be a handle. If he puts it in the front direction, the locomotive will work in the longhood direction. If he puts it in the rear direction, the locomotive will work in the shorthood direction. So when the driver is coming and sitting in the cab, he will bring the throttle, he will put the reverser in a specific direction if he is longhood driving, or he'll put it in the backward direction if he is shorthood driving. Once he has put the reverser and decided the direction of motion, he will see whether all the brakes are in released condition. When he sees that the brakes are in released condition, he will slowly start throttling up or notching up, and that is how the engine starts moving. When the engine starts moving, the rolling stock behind the engine also starts moving. So assume that a train has come, it is at a standstill at a platform, and if he has to restart, he will release the brakes, he will start throttling up and notching up, and the engine will start moving. So this is how the train is controlled by him. So these are some more views. This is where the driver would sit, and here the driver would sit. Correspondingly, there would be one more control stand in the opposite direction where the assistant loco pilot sits. When you are foot plating, and when you are foot plating for the first time, it is always preferable that you stand behind the driver in this place, or you can also stand behind the assistant loco pilot and keep on observing as to how is he running the train, and how the brakes are applied, or how the notching up or notching down is done. It is also advised that you should not pepper him with questions when you are foot plating first, because if you pepper him with the questions, because of your seniority, he will definitely try to answer those questions, but then you are distracting him from driving. The locomotive weighs 120 tons, and at 100 kmph, 120 tons, you are also foot plating. Any distraction may lead to an unwanted circumstance. So that is why when you foot plate, it is always preferable. At first time, you should go with a category of supervisors which is called loco inspector. Loco inspectors is a category which is available with senior DMEs and senior Ds in a division. And these loco inspectors are people generally who come from the running staff category only. So they are ex-drivers, but they have come as loco inspectors, and they are the controlling supervisors now for controlling these drivers and these loco pilots and assistant loco pilots. It is always preferable that you should ask one loco inspector to accompany you, who can keep on explaining to you as to what is being done. So when you are foot plating, besides observing whether the loco pilot is handling the train properly or not, the assistant loco pilot and the loco pilots are exchanging signals or not, you are supposed to observe whether the locomotive is working fine to its parameters. You are supposed to see whether the signals are spotting perfectly or not, whether there is obstruction in the view, whether you have felt a jerk at some location. If you have felt a jerk, that means at that point some track repair may be required. So these are some things which you have to continuously observe. Foot plating on the train or driving a train is a very strenuous work. And that is why there are some hours and some routes which are specified, duty routes are specified for these loco pilots and assistant loco pilots. So this is what a cab looks like. This is an Alco cab. If it would have been a General Motors cab, then you will find it's a centrally located cab, and it is something similar to the traction locomotives, and they control it from a centrally located control stand. In this case, this is the older generation, so you have long hood and short hood independent cabs. This is what a cab looks like from inside. This is what a shed looks like. This is an example of Gutti diesel shed. This shed is homing around 190 locos. Just quickly see what all facilities are there in the shed. So these are some component base. As I told you that the locomotive is having 2000 mechanical and approximately 2000 electrical components. So we need large amount of facilities for maintaining these components. So this is one component where small components are maintained. Again, another look of the component. Now this is the power assembly component bay. I told you that the locomotive is provided with 16 power assemblies. So these are basically the power assemblies. It is something similar to your car or your scooter IC engine. Only thing is the size of the components is different. So this is a power assembly of an Alco engine. This is called a power. This is called a piston, which is basically moving up and down, and this is a connecting rod which is connected to the crankshaft. So once this piston goes up or goes down through this crankshaft, this connecting rod, it is rotating the crankshaft, which gets connected to the alternator. These are the cylinder heads for the intake and the exhaust system. Different ports are there. This is again a view of the cylinder head only, where there are intake valves and exhaust valves. Again, this is a fuel pump support on which the fuel injection components come. Basically, you need a fuel injection component to pump in diesel for burning. Each shed generally would have a small millwright section also, where we would have basic drilling facilities, lathe or shaping, where some minor repairs or activities are done. Again, some examples of sections. So this is the fuel injection equipment which is provided on each power assembly. This is the device which is basically pumping in fuel inside the power assembly to burn. Again, an example of sections only. Now, all the sheds are provided with effluent treatment plants, because the water which is coming out from these places would be is treated water, and sometimes the oils also get mixed in, the lube oils get mixed in. So this is the requirement of the CPCB, the Central Pollution Control Boards, that the sheds should be provided with effluent treatment plants before we dispose of water to the municipality use. This is a inside look of a shed. So the shed is divided into bays. Now this is called a bay. This is a huge shed in which there are different bays you will find, and you will find that the locomotives are standing on these bays. So the locomotive, when it works at rain, it comes inside the shed. It will come and stand on these bays. Okay, and these bays are designed for a berthing capacity. So you will have one loco here, and one loco here. So there are three locomotives on one bay, and the berthing capacity of this bay is three. Now, why this becomes important is because the berthing capacity decides the holding of the shed. If you have more berthing capacity, you can accommodate larger number of locomotives in that shed. If you have lower berthing capacity, you can accommodate a lower number of these locomotives in the shed. These are generally provided with craneage, so you have overhead cranes because they are heavy components, and this is vital space. The under flung area is provided with stilts. So when the locomotive comes and stands here for maintenance activity, from the platform level, you take care of this area, which is the engine area, and you go underneath from this area, from the stilts area, and take care of the bogie components. So the locomotive will come and stand here, and simultaneously attention is paid to the superstructure side and to the undergearing side also. The shed works 24 by 7, so it is completely lighted, and people can pay attention. This is one design by which we can go underneath the locomotive, and this is called a pit. So this is a pit. Basically, once the locomotive comes here, the staff enters the pit. You would also be asked to enter the pit when you are in assistant scale or in senior scale or even in J grade, to see sometimes how the maintenance activities are done. So this is a heavy repair bay. Similarly, you would have 3-4 more bays where there are light repair bays, in which the loco turnout is faster. Light repair is generally defined where the locomotive is turned out in say 6 to 8 hours of maintenance, or you don't need to keep the locomotive back in the home shed for more than 24 hours. From odd hours to odd hours, if the locomotive stays inside the shed, it is counted as ineffective, and you keep such a locomotive in heavy repair bay, and where the locomotive is turned out in 6 to 8 hours only, it is homed in light repair bay where quicker maintenance is done. Again, an example of craneage. This is what the engine or the power pack looks like of a locomotive, and the sheds are also provided with something called a load box. So load box, you see what happens once the locomotive has come out of major repairs, it needs to be loaded. It needs to be loaded with some artificial load, so that the locomotive is able to produce horsepower, and you are able to see the performance of the various components which you have attended. So you may have an electrical load box, or you may have a water load box. There may be a grid, or there may be water, by which you create artificial resistance and you load the locomotive, you increase the power of the locomotive and see the performance of the various components, whether the locomotive is performing well or not. This is another example of traction motor section. Now you see these are the traction motors which are fitted in the bogies. These are traction motors again. Each loco has 6 traction motors. So we have large number of unit exchange pairs for these traction motors. This is the under truck section, or this is the bogie of the general motor locomotive, which is slightly different to the Alco locomotive, but this is a section where maintenance on this bogie is done. This is under truck section again, where this is a wheel set, and you see these are the gears which are provided on the axle. So what happens, the motor will come and sit here in the center. It will have a small pinion, and that pinion meshes with this main gear. So whenever the traction motor is powered and the pinion moves, then it will mesh with these gears and moves the wheel set. So these are all there is a wheel set line where the wheels are waiting. Sheds are provided with wheel lathes. Now this is a pit wheel lathe. That means the lathe is inside a pit. The locomotive will come on top of this in situ and gets machined in situ. I told you that we are supposed to maintain the profile of the wheel. So what happens if the profile has gone damaged because of over usage? The locomotive is taken on the wheel lathe and a cut is given on the wheels in situ, again maintain that profile. So the benefit of this pit wheel lathe is that you don't need to dismantle the bogie. The locomotive will directly come and stand here, and simultaneously both sides the wheel set will get machined to maintain that profile. You would have a painting shop where the locos are painted and used for service. And in some sheds, you will have something called a rail consumer depot, or this is basically a fueling point or a petrol bunk where you are dispensing diesel to the locomotives. So I told you that a fuel tank is there, and this RCD or rail consumer depot or the fueling point is giving fuel to that locomotive before it goes out for service. Now these fueling points are maintained by the oil companies. The infrastructure is owned by the oil companies. It may be IOC, BPC, HPC, or Reliance in some places, but they are manned by railway staff. So a railway fellow would be operating these fueling points, though this infrastructure, these huge tanks would be owned by, in this case, IOC. So this is how a shed looks like broadly, and what are the various bays in which a locomotive is attended. Let us quickly come to this. This is what a WDG4 or a WDP4 looks like, which I told you is an HHP locomotive. And we purchased it in 1995-96. As I told you, it's a two-stroke technology. This is a small comparison just for you to some people who are interested to see what it is. Basically, what you should understand in this is that from the same envelope, that means the same space which is available on the engine, we are trying to draw out more power per power assembly. So in case of an Alco, if it is giving me 3100 horsepower, in case of General Motors, it is giving me 4500 horsepower. So 3100 by 16 is the power which is coming per power assembly. In this case, 4500 by 16 is the power which I am getting from every power assembly. This is also possible because Alco is a 4-stroke diesel, whereas General Motors is a 2-stroke diesel. That means in Alco, for every 2 revolutions of the crankshaft, there is a single power stroke, whereas in General Motors or the HHP loco, every stroke is a power stroke. These are medium speed engines, 1000 RPM. Alco is a 1000 RPM engine, 1050 RPM at its march, and HHP is a 900 RPM engine. They are medium speed engines. This is what the engine of an HHP locomotive looks like. Large number of components which are mounted on the engine itself, and this whole engine is placed onto the locomotive underframe. So we provide this onto the locomotive underframe, and because it is carrying a lot of weight, the underframe is given a reverse camber. So what happens, the underframe in the central location is slightly raised so that once the engine comes and sits on it, the underframe becomes straight. So this is what the power pack looks like. Some milestones as to when the locomotive came in. This was the first G4 with the EMD color scheme, the first P4 which came in 2002. This is the first P4 which was initially made in DLW. Now, I told you that we have moved from DC-DC traction to AC-AC traction, and DC-DC traction used to have a generator with DC motors. Now, if you have a DC generator, what used to happen was the electricity used to come with the help. It is a more maintenance intensive equipment as compared to an alternator. Plus, the flexibility which is available to control AC is lost in DC. The DC power supply is more difficult to control as compared to AC power supply. So this is the technology change which has happened. Initially, the locos were DC-DC. We were generating DC, consuming DC. Later on, it became AC-DC, where we were generating AC and consuming DC. And subsequently, now it is an AC-AC loco where we are generating AC and consuming AC. So this is, you can go through these slides. These are some benefits of the HHP locomotive. When the HHP locomotive was purchased from the General Motors, it came us with this promises that maintenance required would be lesser. The interval of attention in case of General Motor locomotive, in case of HHP locomotive is 90 days. So that means it visits the shed only after 90 days, whereas an Alco locomotive visits the shed after 40 days. That means the availability of the HHP locomotive is much more as compared to the Alco locomotive for traffic use. And with a lesser number of locomotives, you can hold larger number of, with lesser maintenance, you can hold larger number of locomotives in a shed. There's approximate comparison between a Alco locomotive and an HHP locomotive. Availability of an HHP is more, trip schedule gap is more, adhesion, which is the starting tractive effort capability in the HHP locomotive, is much higher as compared to the Alco locomotive. So broadly, two units, when two locomotives are coupled together, it is called a multi. That means two locomotives, they will get coupled to each other and they will work in unison. That is called a multi. So a broad rule of thumb is that one HHP locomotive was able to replace a multi of the Alco locomotive. The balancing speeds phenomena, which I had told you, the HHP gives you a higher balancing speed. This is directly related to the tractive effort potential. The fuel consumption is much lower, and there is another kind of a brake which is available in the locomotive, which is called a dynamic brake. In case of HHP, dynamic brake is available for 48 for majority of the speed range. What is a dynamic brake? I'll tell you later. Just keep it in mind. The locomotive is provided with four types of brakes. There is a hand brake, there is an independent SA9 brake, there is a conjunction A9 brake, and there is a dynamic brake. So the driver would be using these four kinds of brakes in different circumstances. So just keep this thing in mind, and when we come to the braking system, we'll discuss how and when he's supposed to use it. Before that, there is something more interesting which you should know. For example, you are a shed in charge and you are homing 150 locomotives with you. In that 150 locomotives, you are supposed to give 50 locomotives for mail and express service, and you are supposed to give 100 locomotives to freight service. Now, how do you give this? How will the senior DME or the shed in charge know that he has to turn out the locomotive for what service and what use? This is something similar which is there in the traction also and in the diesel locomotive also, because the concept is the same. Now, when you run a train, if a train has to start, Rajdhani Express has to start from Bombay to Delhi. To start the train or to run the train, you need a locomotive, you need the rake or the set of coaches behind it, you need the driver to run the to come and operate the locomotive, and you need TTs and guards. So all these people work on something called links. So every person has a link. Here we are going to discuss what a loco link is. So the shed in charge would be given a link. He would be told that, look, if you have to give 50 locomotives to the mail and express service, this is the logic by which you are supposed to give the locomotives for service in a link. And the shed has to ensure that the locomotives come out from the shed for this service as a link. So let us take an example. It would be easier here. This is a link for a diesel shed, Now, what all does this link tell you? This is a link which has been issued for DLS Guntakal. So this is diesel loco shed Guntakal. A link has been given. This is link number 2, and it is effective from which date it is written here. And it is written that the shed has to give the locomotive to start a train at 7:55. It will start at 7:55 from a place called GTL or Guntakal. The locomotive is supposed to work train number 11303 up to 22:45 to a place called Kolhapur. At Kolhapur, again it is supposed to pick up a train at 7:30 the next day morning, work 11304 up to 21:45 it reaches Guntakal. Next day morning, again it picks up a train from Guntakal at 5:45. It works 57426, reaches Kachigoda at 11:30, which is KCG. Again picks up a train at 16:10, and this is how it works. Okay, so the shed in charge knows that every Monday morning, let us take an example of Monday, starting of the week. At Monday morning, he has to give a loco at 7:55 in the morning on Monday morning to run 11303. And that locomotive, after working this whole link, will come back to him on Saturday evening at 19:45. At 19:45, when it comes at on Saturday evening back to Guntakal, at 19:45, this locomotive will go to shed for its running repair or its light repairs. So the at 19:45 on Saturday evening, this gentleman will take this locomotive for running repairs, and he will do the running repairs and give it back at 7:55 on Sunday morning for train number 11303. So this is how a link is defined, that the senior DME has been told that you are supposed to give a loco in this pattern. So he will give one loco on Monday to run 11303, another loco on Tuesday to run 11303, another loco on Wednesday to run 11303. Okay. And the locomotive which has been given on Monday at 7:55 will come back to him on Saturday at 19:45. He will do a schedule and again give this loco back into this link on Sunday morning to run the same network. Okay, so this link tells him, and you also see that I have put cuts. Now this cut indicates a date change. So when the locomotive has started on Monday morning at 7:55 from Guntakal, it reaches Kolhapur at 22:45 on Monday evening, and Tuesday morning he's supposed to pick up a train at 7:30. So there is a cut here. So there is a date change. There is an orders which has happened, and there is a cut here. So if you count the number of cuts, 1, 2, 3, 4, 5, 6, you know that 6 locomotives are required to run this link. So this will also tell you what is the kilometer earning on an average for this link. So 11303 is earning him 585 kilometers, 11304 is earning him 585 kilometers. From this, I know how much my locomotive is earning on an average when it is working on this link. This link will also tell you that you are supposed to fuel the locomotive at Guntakal when it comes after working 11304, at Hubli when it is working 11303 and 11304, at Kachigoda incoming 57426, 57426. So this link is giving you a lot of information, and the senior DME will give the locomotives for the link for train services as per this link. So it is his responsibility that the locomotive comes out from diesel shed Guntakal after maintenance to run 11303. One thing also to be kept in mind is that these are mail and express links. The light repairs, that means the schedule attention of the light repair where the locomotive would not be kept for a longer duration in the shed, is inbuilt inside the link itself. So from 19:45 on Saturday evening up to next day morning 7:55, he has got sufficient time to do the maintenance on this locomotive. So the schedule time for link locos is inbuilt inside the link. So when he's if he's having 150 diesels and he has to give 50 locomotives to mail and express and 100 to the goods operations, for 50 locomotives he will be given a link like this. For every locomotive he will know that for these 50 locomotives on any day I am supposed to dispatch so many locomotives. Now let us come down. Let us take link number 2A. So he knows that at 22:25 he has to give a locomotive for 11304, which works up to Hyderabad at 6:45. Okay, and this is a bi-weekly train. It is not a daily train. So he knows that on any day he has to give a locomotive in link number 2A at 22:25, 11304 at Guntakal. Now, if you compare these two links and you marry these two links, you will see that 11304 is figuring in the link above also, and 11304 is figuring in the link at the bottom also. Okay, so the 11304 locomotive is coming up to 21:45 up to Guntakal, and here in the lower link also 11304 is figuring. So that means he connects an additional loco here at 22:25 on 11304, and this locomotive goes up to Hyderabad, gets detached here at 6:45 and picks up 17429 from Hyderabad to Tirupati. So these is how the information is shared with the shed, that look, this is how you are supposed to give the locomotives. So every senior DME out of 150 locomotives will pick up 50 good locomotives. That means he'll choose 50 locomotives which are good in performance, and he'll try to maintain them in the mail and express links. Okay. Now you will also see in this link, in the top link, it is written number of locos 6. That means 6 locos is supposed to be given. The type of loco given is WDG3A. Now this is a goods loco which he is operating on this link. Why such a situation happens is maybe Guntakal shed is not having locos which are fit for mail and express. So temporarily he has been given a permission that you can use the goods locomotives on this link. Only thing, the consideration is that no train would be crossing more than 120 kmph as a speed, because G3A has a potential of 120 kmph only. So this link gives you all this information, and for the complete 50 locomotives, he is given this information through these links. You are supposed to maintain that look senior DME, look the shed, you are supposed to maintain the locomotives in mail and express as per these links. When the senior DME is also deciding how he has to keep a loco in a specific link, he is doing something called link balancing. You see what happens, what he'll do is, assuming a loco X is working in the link number 2 for a long time, after 3-4 months, he will try to bring this loco from link number 2 to link number 2A. And why does he do that? When the locomotive is working in link number 2, if the locomotive is getting stressed for a longer duration, he will try to bring this loco into another link where the loco is getting stressed to a lower extent. That means where the locomotive working is not so strenuous that the components are getting stressed. Secondly, assuming that from Guntakal to Kolhapur, when he is working in a specific direction every time, he will find that the left hand wheel is wearing out more as compared to the right hand wheel, right side wheel. It happens because of track inclination, cant, curves. You may find that the left side wheel is wearing out more as compared to the right side wheel. He will try to switch this from link number 2 to link number 2A, where he might have observed that the right side wheel is wearing more as compared to the left hand side. So what will happen if he keeps on interchanging the locomotives between these two links? He will find a uniform wear pattern in the locomotive wheels. So these are all calculations which are done, and at the zonal railway level, the headquarters will issue these links to every shed. So the headquarters will know that Gutti, you are supposed to give so many locomotives for these trains. Kazipet, you are supposed to give so many locomotives for these trains. Guntakal, you are supposed to give so many locos to these trains. And what it's kept in mind is that if you see in the lower link, I have written something called light engine or LE. So what is kept in mind is the effort is always that you should have as less possible light engine movement, because it is useless. You are wasting the resource. You are wasting a path to take a locomotive light. So you basically try to ensure that the locomotive has minimum light engine movement. Now, this link also can cross zonal barriers. So, for example, a train can start from Secunderabad and work up to Bombay. So, it crosses South Central, it crosses Western, it crosses Central. So, the locomotive from Secunderabad may go up to Bombay. At Bombay, it can pick up a link from Bombay to Kolhapur, from Kolhapur to say Satna, from Satna back to Kolhapur, from Kolhapur back to Bombay, from Bombay back to Secunderabad. Only benefit of this link is that at any point of time, I know where my locomotive is, and we try to ensure that the locomotive, the mileage earned per link is approximately 5,000 kilometers. We do something called link balancing. Or a scenario may happen where the train is going from Secunderabad to Bombay. The locomotive may be going from Secunderabad to Manmad and getting detached there, picking up another train, working back from Manmad to Secunderabad, and the Western Railway locomotive picks up from Manmad to Bombay. If any question is there, you ask me. If there is no question, I would request that you put your mic in mute. Otherwise, I'll have to mute you all from here. Okay. So this is the link. Okay. So there are some questions here. I'll address the question. अरे तुम्हारा वाईफाई बंद हो गया तो माइक तो बंद करो कि तू लिंक सबको म्यूट कर ओके Now the question is, sir, how is your experience working in mechanical department in South Central? Which one do you recommend for provisional for opting South Western or South Central? This is, I think, a question which is too early in your service span. It hardly makes a difference. सारी रेलवे 19-20 हैं, कोई फर्क नहीं. Voice is restarting. How does pilot fine tune speed using throttle handle? As I told you, that the driver either notches up or notches down. The driver knows that if he notches up, he gets more power and he can, the engine will speed up depending upon the road conditions. So he does a judicious mix of the throttle and the braking system. So his both the hands are working always. So you will find that the drivers, when they are starting from a platform, they will notch up faster. That means he's asking for more power and he'll take the locomotive directly up to the eighth notch. And that is why when you see locomotives coming out from these stations after stop, a large amount of huge black smoke is spilling out. What was happening? The driver has asked the engine to produce more power, but there is something called a governor, which is trying to balance the speed with the fuel consumption, and there is a lag. During that lag period, the thick smoke is happening. Once the driver has gone to the eighth notch and he has asked for more power from the engine has touched the speed. The driver will bring the notch down to either sixth notch or seventh notch, and that is called coasting. Because on sixth notch or seventh notch, when he's coasting, the fuel consumption performance of the engine is the best. You see, the drivers are given something called fuel rations. Each driver is told that if you have to take a train from Baroda to Ahmedabad, you are given 200 liters. So he is supposed to consume 200 liters, and we keep on monitoring the drivers whether he is consuming more than 200 liters or whether he is consuming lesser than 200 liters, and the drivers accordingly are either taken up or counseled. So every driver, this is the aspect which you have to monitor when you are foot plating, whether he is handling the locomotive perfectly or not. So he fine tunes the speed with a judicious mix of the throttle handle and the brakes. After turning, is there any requirement of heat treatment? No, there is no requirement of heat treatment. The locomotive wheels are simply turned and they are given back for service. What is the hierarchy of staff in workshops after CWM? Will there be any senior DME in the workshops? There will be no senior DME in the workshop. The workshop is headed by a chief workshop manager. Underneath the chief workshop manager, who is generally in SAG, you will find officers in JA grade and senior scale and junior scale. And there they are named as deputy CME workshop. So there may be a deputy CME production, there may be a deputy CME tooling, there may be a deputy chief electrical engineer, there would be a deputy COS. So there is no senior DME in the workshop. Senior DME is only there in the divisions. Please explain light engine again. Light engine is when the locomotive is not working a train. Now let us, if you take the example of link number 2A, train number 17430 has worked from Tirupati to Hyderabad. Okay. And as per link, this gentleman, this locomotive is supposed to pick up now a train from Secunderabad to Pune. Okay. So to take the locomotive from Hyderabad to Secunderabad, the locomotive is sent light or it is sent alone. There is no train behind it. So the locomotive will be sent light. And why this light engine movement is a waste movement? Because this distance is 15 kilometers approx or 10 kilometers approx. The locomotive is working for 10 kilometers without giving you any earning. You are wasting a driver to take the locomotive from Hyderabad to Secunderabad, and you are wasting a path. That means in that path you could have pushed in a train, which would have given you some earning. But a light engine, when it enters the section, also blocks the section. You cannot push in a train because a light engine is crossing that section. So that is why light engine movement is always avoided or minimized as far as possible. This is called light engine when the locomotive is going alone without the train formation. How the driver manages to see signals in foggy winters? Yes. So till now the instructions were that whenever the foggy winters come in and he is not able to see the signals, he is supposed to run the train on restricted speed. Depending upon the visibility of the signals, even if the section is cleared for 100 kmph, you may find that the driver is running at 15 kmph and he is trying to, because he knows heuristically where the signal is located, so he will go with a very cautious speed at 15 kmph, see the aspect of the signal and then go ahead. This was the situation which used to happen, and that is why you would hear that Punjab Mail is running 3 days late or 2 days late, because in foggy condition the driver is not able to see the aspect. Now there is a device called fog vision which is under development, and where cameras are fitted on top of the locomotives, through which he is able to see the aspect of the signal. IIT Kanpur is working. There are two technologies on which they are working. One is called Netra Vision and second is fog vision. So these devices are fitted on the locomotives by which the aspect of the signal gets replicated in the cab itself for the driver to see. And then he drives it on the basis of those signals. How are coaching depot officers different from officers who work in workshops in sheds? It is incidental in the sense they are all mechanical officers. A coaching depot officer, when he gets posted in a coaching depot, he is looking after the maintenance of coaching staff. He's looking after the maintenance of coaches. Tomorrow, the same officer can go and get posted in a workshop where then he will have to look after the maintenance activity or a manufacturing activity, or if he goes posted in a shed, he has to look after the maintenance activities of the locomotives. So these are different spheres where you keep on getting posted, and wherever you get posted, you are supposed to provide technical wisdom and guidance to your staff and supervisors during your stay there. Sir, due to any extraordinary situation, if the staff of a shed fails to return back the loco on a scheduled time which entered the shed for maintenance, then what are the possible options the in charge of the shed can exercise? Okay. Now, yes, this is a good question, and this we could have answered later on also. But you see what happens if the shed has been given, if the shed is holding 100 locomotives, and he has been told that you're supposed to give 50 locomotives to for mail and express and some locomotives to the freight operations. He is given some numbers of spares, and that is an effective percentage formula which we'll see later on. So in 100 locomotives, he would be given 10 locomotives as spare, and he would be asked that assuming a mail and express locomotive fails and you are not able to return, so the shed in charge will pick up any one of these locomotives, and he will provide it for mail and express services. Under no circumstance the shed in charge would have a situation where he is not able to provide a locomotive for a train service, because then the train service would either get cancelled or it will get delayed. In both the circumstances, he will be hauled up as to why your shed has not been able to provide a locomotive from a train. So we have no situation where Bombay Rajdhani has got cancelled because a locomotive could not come. Because if Bombay Rajdhani gets cancelled, if a locomotive does not come, then that senior DE will be taken over coal, hard burning coal. Okay, he has to answer why the locomotive did not come to for train operations. So no senior DME or senior DE or a shed in charge would play with a link. With the link, he will 100% ensure that the locomotive is always available for the train, for the link, for to run mail and express trains. Okay, so you have understood the link. Okay. Good. Because no answer is coming, I take that you have understood the link, because I'll give a numerical on this link in the question paper. I'll move ahead. I told you that the shed is supposed to give the shed gives locomotives for mail and express trains. The shed also gives locomotives for freight trains. So if he is having 100 locomotives, we have said that 50 you will give as per mail and express, the balance you will give for freight operations, and we are also supposed to give him some locomotives as maintenance spares. Now the definition is, if the loco is not available for whole calendar day, that is from odd hours to 24 hours, then it is counted as ineffective, and a percentage of 10% is permitted to a shed for ineffective holding in case of alco locomotive, and 5% if the shed is having HHP locomotive. So if it is an alco locomotive shed, his net target availability is 81% of the holding. So if he is holding 100 locomotives at any point of time, he is supposed to ensure that 81 locomotives are working on line, either in mail and express or in freight operations. So let us take an example. The shed is having 100 alco locomotives and he has got a link of 40 locomotives. Okay. I also told you that the light repairs of the link locomotives is built inside the link. Now he is having 100 locomotives. In these 100 locomotives, he is supposed to give light repairs and he is supposed to give heavy repairs both. And this gentleman has been told that you are supposed to maintain 40 locomotives for mail and express. So once he has got 100 locomotives, he has been given a freedom that 10% of these locomotives you can keep for heavy repairs. Now in heavy repairs, you have yearly, 2 yearly, 4 yearly, POH, rebuilding. Wherever the loco is supposed to be ineffective for more than one calendar day, gets accounted in this 10%. So if in 100 locos, he keeps 10 locomotives for heavy repairs, then he is left with 90 locomotives. Now, in this 90 locomotives, he has to be given some spare for light repairs, where he is doing part schedules. Now, also remember that the light repair of the link locomotive is built inside the link itself. So, out of this 90, he has given 40 to the link. So, he is left with 50 locomotives. Now, these 50 locomotives are the possible locomotives which can be given for freight service. When the locomotive is given for freight service, they don't work to any link. They go out on day one, and it is said that you are supposed to come back to me after 40 days or say 30 days, and you can work anywhere in the country. So you have to give some percentage of spares against the freight locos for him to do light repairs. So you give another 10% spares as light repairs for the freight locomotives. So out of 50, you give 5, you are left with 45 locomotives. So now this shed will give 40 locomotives for mail and express in a holding of 100 and 45 locos for freight operations. He has given effectively 85 locos, and at any time of the day, he is supposed to maintain these 85 locomotives on line. When he is giving the locomotives to the freight service, it is called outage, and that is a parameter which is monitored. So on say Monday, he will give 40 locos for mail and express, and he will give an outage of 45 locos for freight operations. At 12 o'clock in the morning, he will see that I am maintaining an outage of 45. At 12:30, he will see that his outage has dropped to 39. That means a locomotive has come inside the shed or it has failed. Then he will try to build the outage up. Again, he will take the outage to 45. The parameter of performance of the shed in charge is the outage, because everybody knows that the shed in charge will not mess up with the link loco. But if his link is not working fine, his outage will drop. If his maintenance is bad, he is having more number of locos inside the shed under repair, he will not be able to maintain the outage. So his outage is monitored. Traffic will tell him that I need an outage of 45 from you. I need 45 locos from you all the time. So for 24 hours of a day, 45 locos are out, and the senior head in charge, the headquarters, the traffic, the general manager, everybody is watching the outage of that shed. Sometimes you will find that they say that the outage of the shed is 45.2 or 45.4, and that zero point 0.4 comes from the term that a locomotive, an additional locomotive was available for 24 into zero point 0.4 number of hours. So that is why if you are in charge of a shed which is having both link and freight operations, you will find that you will be constantly bombarded every time for your outage. If a shed is good, he will maintain a plus outage. If the shed is bad, he will maintain a minus outage. If he's maintaining plus outage, that means his maintenance is good, his ineffective is down, his ineffective is lesser than 10%. If his maintenance is bad, his ineffective is more, and that is why his outage is dropping. At the headquarter level, the CMP diesel has to, say in South Central, has to maintain an outage of 260 for freight operations, and he finds that Kazipet outage is dropping, he'll tell Gutti that you build up the outage, or he will tell Guntukal that you build up the outage. So this he constantly monitors, because traffic at the headquarter will say, I need 260 locos as outage. You provide me 260, how you provide it is up to you. So in front of traffic, the CMP diesel will ask an associate shed to build up the outage. Independently, he will ask Kazipet why your outage is dropping. So that is why outage as a term you will hear in every meeting, everywhere it would be asked, what is the outage, outage, outage? Because outage is required to run freight trains. And if the outage drops, you end up losing freight trains and you end up losing earning capability. So the traffic, the GM, every person is monitoring the outage. Now, I told you that this targets of ineffective for ALCO is 10% for heavy repairs and light repairs. In case of in case of high horsepower locomotive, this ineffective permitted is 5% and 5%. So you can do a reverse calculation again of this 100 locomotives. If it was a HHP shed, what would be the outage of this shed if the shed has to give 40 locos for link? Okay, so if we rework, like in case of Alco, we said that the outage is 45. Assuming if it was an HHP shed and I rework it, again with 100 locomotives, 5 locomotives go for heavy repairs. I am left with 95 locomotives. Out of 95, I have given 40 for mail and express. I have left with 55 locomotives. In 55, again, I multiply it with 0.5, and the outage of this shed would be defined somewhere around 51.25 or 51.5. So any day if this was an HHP shed, the shed in charge would need to maintain an outage of 51.5, and everybody would monitor only the outage, because link anyway, you will ensure that the locomotive goes out for link service. There's a worked example. Once I share it, you can have a look how it is calculated. There's an example here again. Now we'll quickly come to what is the brake system in the locomotive and in the train operations. I told you that the brake system which is provided works on pneumatics, and these are some desirable features which should be there in the brake system. Every component which is related to safety in train operations is designed with the concept of fail-safe in mind. That means, assuming if a signal fails, the signal will always fail to the aspect of red. That means it should show danger. Assuming a train parts, the fifth coach and the sixth coach has separated from each other, then your braking system should have the capability to apply brakes automatically. So that is called fail safe. So the system should, the brake capability should be there, that it is a fail safe system. Brake should apply as fast as possible. I have applied the brakes from the locomotive by destroying the air pressure with the help of an A9 brake. Now, each coach is approximately 30 meters, and you assume there are 20 coaches behind. So, the last coach is at 600 meters. So, the propagation rate of this brake application should be fast. Otherwise, what will happen? I have braked the locomotive, I have braked the first coach, second coach, third coach, but the last 20th coach, if it breaks after 5 minutes, in that time, so much stresses will come on the interconnected couplers that they will break. So that is why the brake propagation rate should be fast. The brake should simultaneously apply on each vehicle. This is again related that it should have a fast application. The brake force should not reduce with passage of time. Now, this is what happens, that if I have applied the brakes and the train has come to a standstill, it should not happen that the brakes start releasing automatically. Once I have applied the brake, it should not happen that there are leakages or the system permits the brakes to release by itself. Assuming the train is standing on a grade and I have applied brakes, and if this situation happens, the train formation, the brakes release, and the train will have a tendency to roll down. So these are some desirable features which should be available in the pneumatic braking system of the train formation. So these are different types of brakes which are available on the locomotive. There is a hand brake. This is a simple mechanical lever system. It's a mechanical brake, and the driver will use these brakes when the locomotive is in dead condition. Assuming the locomotive has been made dead and it is placed in siding, so he will apply hand brakes so that if a train comes onto the corresponding line, because of the vibration, the locomotive should not have a tendency to roll down. If it rolls down, it will come and hit the adjoining train. So he will apply these mechanical brakes, and he'll provide something called skids. Skid is something similar ki agar aap ek car, if you park a car on a incline, you will put stones underneath the wheel, just as a safety precaution measure, that if the handbrake gets released, this stone is able to stop. Something similar in the locomotive, you have a handbrake by which mechanically you have applied brakes, and you provide something called skids so that the wheel does not have a tendency to roll. Automatic air brakes are those convention brakes which we have spoken. Independent locomotive brakes are that independent SA9 which we have spoken. The fourth category of brake is a dynamic brake. Now this is an electrical brake. What happens when the locomotive is working and the driver has applied dynamic brakes? The motors start working as generators. We reverse the field so that it starts generating electricity. So this is a brake which is applied with the help of traction motors, and this is called dynamic brake. The current which is produced in the traction motors is either burnt in the grids. So there are some grids which are provided in the locomotive, or in case of traction locomotives and new generation diesel electric locomotives, you would have heard a term called regenerative braking. So whenever such a braking happens, the current which is getting produced in the traction motor gets pumped back into the catenary. So these are called regenerative braking systems, which is possible with the help of dynamic brakes. Hand brakes are provided on all locomotives, cars, wagon stocks, coaching. These are some brake systems, these are some names. What you should only remember is that as of now the locomotives are provided with a pure air brake system. IRAB is a code which RDSO had given, and it is a set of 30-40 valves which are connected to each other through which the braking action happens. And now CCB is a computerized controlled braking system which is provided in General Motor locomotives. This is microprocessor controlled braking system. The basic valves are still the same. Only thing is we have made a microprocessor to sit on top of the braking system so that we can send control signals with the help of a microprocessor. So this is what is the latest in the locomotive. We'll talk about CCB later on also. And this is one definition that how do we classify the failures? We classify the failures in statistical and non-statistical category. Again, in a shed, the shed in charge has parameters, some parameters which are his key performance indicators. And the key performance indicators are what is his ineffective, what is his outage, what is his lube oil consumption, what is the number of statistical failures and non-statistical failures which his shed has given on reliability. Okay, so these are some parameters which are monitored on the shed's performance, and these are some new technology progression items which have got added on the locomotives. So the first thing is called an APU, or it is an auxiliary power unit. What we have done is we have provided a smaller engine inside the locomotive. When the main engine has to stop for more than 30 minutes, then the smaller engine kicks in and it keeps on feeding the locomotive with compressed air and battery charging. So this is called APU. MLOT is a remote monitoring device which we have fitted. It is a GPS enabled device which continuously monitors the health of the engine. Common rail electronic direct injection is a kind of a fuel injection system which has followed the automobile technology. It is a step ahead of the electronic fuel injection system. So this is there on the locomotives. We have started blending our diesel with something called biodiesel. Now, biodiesel is also a cetane fuel with similar properties as compared to that of diesel. And Indian Railways has adopted the policy of blending our diesel with 5% biodiesel. We purchase diesel to IS 1460, that is the parent specification, and that specification also permits blending it with biodiesel by 5%. DPCS is something called distributed power control system. This is this is a device which is used for long haul operations, where you're basically trying to couple two trains together. In freight operations, you have a 58 boxen plus a 58 boxen together, and you provide a locomotive in the center. Then you use this device, which is called distributed power control system, and you can control the rear locomotive with the front locomotive only. We are working on specific fuel consumption, which I showed you in the figure. We are working on reduction on emissions. Now, emissions in the world for railroad applications are followed to US EPA standards. As I told you, Indian Railways follows United States conventionally. So there are EPA standards, United States Environmental Protection Agency standards, which is something similar to BS1, BS2, BS3, BS4, which is there in automobile, road automobile in India. So there are US EPA standards, and Indian Railways also tries to follow US EPA standards, and we are working on reduction of emissions. In place of diesel, we have run diesel electric multiple trains on CNG. Unfortunately, we could not run them on LNG, and some demos, especially in the northern sector, if you go from Shagur Basti to Saharanpur side or Shamli side, are all running on CNG. There's a new concept called hotel load, which you keep in mind. I'll cover it during the coaching stock because it is more related to the coaches. But the loco is supposed to be HOG enabled. So this we'll see later on. I will end this first presentation, which I was supposed to do in S1, S2, but I had to go a bit slow. And the session is up to 13:15. So I'll start with the second presentation. If you have any quick questions here, I can answer you this. Otherwise, I'll start covering the second aspect, what the mechanical looks like. Okay, some questions have come in. Sir, can you illustrate a numerical on availability which will make it more clear? The numerical on inbuilt inside PPT. Don't worry, I am going to share this PPT with you so you can see it there. If you are still not able to understand, I am willing to have a face-to-face interaction. You can come in small groups and I can explain it to you. Or if your CD holds a doubt clearing session in Manthan or somewhere in small groups, you can come and I can explain it there. Any future of scope of gas turbines in trains as they may help in attaining high speed? You see, gas turbine locomotive was developed by Russian railways. Trans-Siberian Railway works on turbine locomotives, which are 12,000 horsepower locomotive. And to develop a gas turbine locomotive was thought of in Indian railways. But the problem was that only one railway was running it. And the basic problem with usage of gas turbine is how to control the exhaust. You see, when the gas turbine is used, the volume of exhaust which is coming out becomes immense and you cannot have a vertical stack. So you need to redesign the exhaust system in gas turbine. And gas turbine is no fun if it is made in smaller horsepower ranges. So if you have to have a gas turbine locomotive, you have to work in the range of 11,000 to 12,000 horsepower, which the Trans-Siberian Railways did. Plus, the acoustics becomes a problem in gas turbine. And why Russian Railways was successful because it was running it in Trans-Siberia, that also only as a demonstration locomotive. So gas turbine as a project was thought of but has not been taken. Next question is which fuel type or grade used in diesel locomotives? We buy fuel to IS 1460. You can Google out IS 1460, and we are latest BS4 compliant less sulfur diesel, which we are purchasing. So Indian Railways has always tried to reduce the sulfur content in the diesel. But incidentally, why you have asked this question, then I'll explain. You see what happened, the sulfur used to act as a lubricating agent for the fuel injection components also. So when Indian Railways went on the path of buying diesel with less and less sulfur content under IS 1460 BS4 grade, so we started having a problem of self-lubrication of the fuel injectors, and that is why biodiesel got introduced. Biodiesel as an additive also has very good lubricating properties. So now that is why IS 1460 diesel is getting blended with biodiesel. Even though we move towards the regime of low sulfur, the biodiesel gives me the lubricity in the fuel injection components. Please explain 50.5 outage. How many locos are involved in this figure of 50.5? 50.5 means that on any day, you see, you are a part of railways, you should learn two things very quickly. First, start loving acronyms. Second, start thinking in terms of a 24-hour watch. It is odd hours to 24 hours. It is not 4 p.m., it is 1600 hours. It is not 5 p.m., it is 1700 hours. Now, 50.5 means at 1300 hours, if the outage is 50.5, that means that shed has given 50 full locos for 24 hours for usage, and has given one locomotive for 12 hours usage. So 12 hours by 24 is 0.5. At 13 hours, his outage is 50.5. If at 1600 hours his outage is 50.8, that means 0.8 into 24 is the time for which he has given an additional loco. So in the division, there is an organization called Power Control Organization. In every division, there is a control center, there is a control room where representatives of every departments are sitting. So there would be an engineering controller, mechanical controller, power controller, carriage wagon controller, traffic controller, who are monitoring these locos, these operations, the running operations of these locomotives. So that power controller 24/7 is monitoring how many locos out and what is the outage of that shed. So at 1300 hours, he will say that this shed has given 50 locomotives plus one locomotive for 12 hours. So his outage is 50.5. At 1600 hours, he will say this shed has given 50 locomotives plus one more locomotive for 0.8 into 24 hours. So that is why his sheds outage is 50.8. So power controller as a person is monitoring this outage at an hourly basis, and this outage figure is repeated at every 4 hours to everyone. If you visit any shed, you will find that the shed in charge would have a electronic watch in front of him in which his hourly outage always keeps on scrolling. So he keeps on monitoring as to what is his outage, because that is his prime indicator of his performance. And if his outage drops, he gets killed. You are asking me so many questions, not letting me go to the second presentation. Will there be any locomotives based on CNG as a fuel till now in IR? Yes, we are having diesel electrical multiple units which are running on CNG. It is not purely CNG, it is blended CNG. You see what happens? There are two, three technologies by which you can induct CNG into a power assembly. So there is something called high pressure direct injection or HPDI technology, which has been developed by a company called Westport in Canada. And they have developed it basically for trucks. If you go to Australia, you go to Europe, you will find that the trucks are running with HPDI technology with pure CNG. And basically, it is not CNG, it is LNG. But when the LNG gets evaporated, it enters into the system as CNG only. So HPDI is one technology which is called high pressure direct injection, where you are injecting natural gas directly into the power assembly. There, the locomotive or the truck is working with 100% CNG. In case of Indian Railways has converted around 2025 diesel electric multiple units, where we have adopted the method called fumigation, the natural gas into the intake air stream. And the air which is going inside the power assembly is a mix of air and natural gas. This is called fumigation, and we have been able to substitute diesel consumption by 20%. So if a demo is run now, earlier if it was consuming 500 liters of diesel, now it consumes 400 liters of diesel and some X quantity of CNG. CNG is an octane fuel. Please remember, CNG is an octane fuel. Diesel is a cetane fuel. So with this fumigation technology, you cannot go beyond 20% because there is something which is called combustion flame front and pressure knock. So we will leave it at this. So we have adopted fumigation technology and we are running our demos with 20% substitution of CNG. So there is no locomotive as such planned as of now with 100% injection of CNG. Our project was taken, but it got shelved, where we planned to associate with Westport and develop a locomotive with HPDI and LNG. It didn't come through. Any more? Okay. So there is no further question. You are lucky people. We can start with another presentation. I still have 10 minutes. So before you go for lunch, I would give you something more. I'll start with the second presentation. Stop sharing. And let me open another PPT. Okay, so you would see here the first slide I've written running. It is visible.
Yes, sir.
Yes, sir.
So we assume it is visible, and I'll move ahead.
Yes,
Now,
sir.
I told you that under the DRM there were 4 5 fellows who were sitting. One was CNDM diesel, CNDM power, CNDM CNW, CNDM ENHM. So now broadly we'll quickly discuss as to what the CNDM power or the operations does. In all the divisions where predominantly diesel locomotive is being run, these activities are done by the mechanical officers. Wherever electrical locomotives are running, these activities are predominantly done by electrical officers. Wherever there is a mix, the DRM would have distributed. So what does this gentleman do irrespective of mechanical or electrical? These are broad activities which he does, and quickly just see what all he does. So first thing is he is in charge for the running staff. Now, in this case, the running staff for him is the loco pilot and the assistant loco pilot. So a division would be having around 300, 400 odd loco pilots and assistant loco pilots. So he has to control them. He has to ensure that the loco driver comes to run the train. The loco pilot is trained. The medical of the loco pilot is done. Whether he's going on sick leave, absent. So all that activity he does. He is controlling a large number of crew lobbies. Now, crew lobby is nothing but an office where the loco pilots would come to sign on or sign off from duty. On platforms, you would see towards the end of the platform there would be one kind of an office where large number of drivers are going in or going out. So they are basically called crew lobbies. Running rooms are basically rest houses for the drivers, for the loco pilots. These are facilities which are extended by the railways. That if a loco pilot comes working after a train, he can come and take rest in these running rooms. He is controlling the RCTs or the rail consumer depots, which are the fuel bunks. So the division would be having number of fueling points where the locomotives are getting fueled. He is controlling the accident relief trains, the disaster management trains which are available. There might be two, three type of equipment. There might be jacks. There might be cranes. So he is in charge for that. Large amount of fuel is used, dispensed with on consumer in these RCD controlling that. And the last is MMC, which is mismanagement by crew. Sometimes the locos do get failed because of and lack of knowledge by the drivers. So he has to continuously upgrade the knowledge of these drivers. Now, when you come to the railways, you will find that you get a morning position. So the position in railways flows every day, every minute to run the trains. There's just an example of what a position looks like. Every electrical might have a different position pattern. Engineering might have a different position pattern, but you get this position from that gentleman, which is power control, which I told you is there in the division control room. And the power controller will keep on giving you these positions. And this is one position which is of a morning position, which comes at around 6:30 in the morning to you as to what has happened in the last 24 hours in your division. So this is one position which comes, say, for example, he'll tell you what is the shed outage of the last 24 hours, whether sand is available or not. Now, these TP 103, 104, 106 are basically transportation codes, which will tell you if a train has worked, whether any detention was experienced in that train. TP 104 will tell you what are the details of the locomotive which has failed. TP 106 will tell you where all the locomotives are available. TP 101 will tell you that in your division, if a shed is there, how are his locos distributed? What is the ART status, whether the accident relief train which is available in your division is available for use or not, and a punctuality summary per se as to what has happened in the last 24 hours. So this is like, for example, it's an old position but doesn't make a difference. It is the same for 21/12/16 on 20/12/16. So many trains lost punctuality over South Central, and why did they lose? What were the repercussions? What has been the failures in this? So this sheet will tell you what all are your failures, how the locomotives are distributed. This is TP 106, and this gives you 101 as to what are wherever are your locos. So it's just an example of the distribution of locos. Don't take it. Every branch would have its own mechanism. The concept which I am trying to tell you is that every day morning you would be getting this position in some way or the other. Like this is one position which comes to you. What does the multiple consist? Now, don't see the position per se, but try to understand what is a multiple and what is a single. Now, when the locomotive is coming out from the shed, till now I've been telling you that 40 locomotives are coming out to the from the shed for goods services. Assuming the traffic department says that I am having a 4700 ton loaded train and I need a multi. Now, a multi is where I marry two locomotives to each other and I turn out from the shed as a multi. So, I will provide some power cables so that the rear loco engine is also controlled by the front locomotive itself. So, a single operator, a single loco pilot who is sitting in the front locomotive is able to draw power from two locomotives simultaneously. This is called a multi. If he is running single head, that means he is having a single power and he is working on a single power. So this gives you a disposition as to how the shed has turned out, how many single heads and how many multis. And why this becomes important? For every locomotive, you need driving crew. So if the shed has turned out 40 locomotives of single head, you need 40 sets of crew. If the shed has turned out the 40 locomotives as 10 multis and 20 single heads, then you need 30 sets of crew. So that is why this position comes out and the traffic department tells in advance that I need the locomotives either as multi or I need the locomotives as single heads. Okay, so that is why this position becomes important and it is monitored as to how many multis or how many single heads are available at any point of time. So it is 13:15 and I'll end here. If there are any quick questions, you can ask me now. Otherwise, we'll continue from this slide in the next presentation. Okay, so there are no further questions. I'll request your CRs. I think I have their numbers. So the first PPT I'll put in the WhatsApp group for the CRs. They can share it. Okay.